Here we're going to take a look over the different light types that are available in Lightwave and examine the differences between them. Now, this is just going to be an overview of the basics of the lights as a whole. There are a few specifics that relate to certain light types, and we'll come along to all of those individually as we work our way through this set of videos. So let's start out here with the good old distant light, which is the regular default light. Just hit up VPR, and of course we can see there we get our render with our object shadow. We'll turn on the OpenGL just to let us see a couple of things. Let us first of all have a look in the light properties panel, and you'll see that we've got the basic options here for a light, such as, the color that we want it to be lighting things up with, the color of the light itself, the intensity. We've got nodes here that allow us to edit the intensity fall off. We'll see more about that afterwards. We've got various activations, inclusions or exclusions for what we want the light to or not to affect. Settings for shadows, of course. Exclusions for objects, we'll look at that more in depth a little later. Buffer group we'll look at again. Volumetrics for volumetrics. And the number of samples used, which again we'll look at when we come to sampling specifically. These are the main settings that you'll find on all of the light types, and they are pretty common, including this one, visible to camera, which allows the lights to actually be seen by the camera as if they were objects. So let us start out here with the distant light, which is the standard default light that we get in any scene. The distant light is intended to represent light that is coming from a distance. What sort of distance? Effectively infinite. As such, one thing that you'll notice with the distant light is that its position has absolutely no bearing whatsoever on its highlights and shadows. You see, I can have the distant light here off behind the object, and yet it's still casting the shadow in that direction. The only thing that matters with distant lights is their orientation, like this. As such, distant lights are usually used to represent something like the sun. Just a source of light that is so far away, it's as if its rays are parallel to one another. So of course, usually with lights, we tend to think, of course, as the light object or the light icon as the source from where the light is coming. That's not so with a distant light. With a distant light, we think that it's coming from an infinite distance away along the direction that the distant light is pointing. So that's pretty nice and straightforward. One thing to notice with the distant light is that it has an angle setting here, which is an angle away from parallel for the rays, and you can see that as we increase that, then the shadow from the distant light starts to soften out ever so slightly. If you're used to previous versions of Lightwave, this is basically a dome light now. So if you set it to something like 90 degrees, then you have very soft shadows indeed. Effectively, it's light, you can think of it coming from an infinitely distant and infinitely large dome with an angle of 90 degrees. Another way of thinking of this angle is in terms of the hemisphere that would represent the sky, right? You go from horizon to horizon in every direction. The sky is kind of like this hemisphere over the top of us. That is sort of what the angle represents. And so if you go to 180, then you've got essentially a full sky dome type lighting, and you'll see that there's no particular shadow in any direction. The light is sort of omnidirectional over the entire object. Why? Well, because it has no focal point anymore. In the case where we are using this to represent something like a sun, or the sun specifically, then again, if you imagine the sky as this dome that goes from one horizon to another as 180 degrees, and you think about how big the sun is in the sky, then one way of measuring the size of the sun, and in fact the common way of measuring things on the sky that is used, is by their angular size. So the sky is 180 degrees from one horizon to another. How many of those degrees does a given celestial object occupy? In the case of the sun, it's around 1/2 a degree. So this is quite a common setting to use on the distant light if you're wanting to use it to represent the sun. Also notice that when we turn visible to camera on, there's no visibility here at the light's position, again because it's taken to be infinite distance away, but if I roll my camera or my view around like this until I'm looking off in the direction of the distant light itself, then there it is. Let me just temporarily hide my figure that's in the way of the view there. You'll see if I line up my view exactly with the direction of the distant light, there is the visible light essentially off in the backdrop there. And you see of course that the appearance of that is linked to the angle. When we have 0 degrees then it's not visible at all, but as we go up through the sizes then of course it gets bigger. It occupies a greater angular size of the sky. You'll notice as well that the angle there also affects the specular highlights and effectively the reflections of the light in other objects. Again, because the light is kind of like having an actual object, and specular reflections actually show a reflection of the light object, then of course little changes to that will affect not just these shadows but also these speculars. So let us look next at the spotlight, shall we? Obviously sort of similar idea, at least conceptually, that we might think to the distant light, except it's not, because this is now actually coming from a given point. It is a spot of space that the light is coming from. It's just like a spotlight that you would see used, in a film studio or on a stage or similar. Again, it has an angular size like this that you can set, which is the size of the overall spot cone, and it also has a soft edge. You'll notice that the spotlight will give a nice softened edge to its illumination, and you can tighten or sharpen and soften that in this way. And of course you can see that you have the icons there. Now, one of the things that the spotlight has that some of the other lights have as well is a size, and you can see that by default that just is 0 here, so it's as if it's an infinitely small light source. However, we can increase that, so let's just try it at something like, 100 millimeters, shall we? And you see that our spotlight now forms an actual disc, and it is from the edges of that disc that we can of course see our spotlight is being drawn, and we can also see that of course that changes the cast of the cone there. Furthermore, it has an effect on our shadow. As we increase the size of the spotlight, the shadow that is cast becomes softer and softer. So with a sized spotlight we're getting a nice soft shadow, and of course when our spotlight size is 0, then because it's a point light source we get these very sharp shadows, in fact perfectly sharp shadows. You may have noticed as well that when we've got that size up, then the spotlight is showing as a disc as being visible to camera. Now, another thing that the spotlight has that some of the other lights have is this option here for projection image. So we can load up some image. In this case I've got this stained glass window image, and you can see of course that the spotlight then projects that image. It is like having a light in real life and just sort of slotting a semi-transparent image in front of it so as that image is projected out. Now the spotlight, like other lights that have a projection image, have this setting which is miss samples. This is multiple importance sampling. So this allows for the image to be importance sampled. So of course areas where the image is turning the light dark versus areas where it's turning the light light. That can be pre-scanned in order to importance sample the detail of the lighting there. Now we get another option that appears on these lights that have, actual physical size to them, and we see that if we pop over to the shadows tab here, where we have an option cast shadows. Again, this is another instance of lights behaving somewhat like objects. They show up in specular reflections, they show up directly to the camera, and they can also cast shadows. So let's just demonstrate that swiftly. I'll make a clone of this light, and we'll just move it off some so that it's, partly in front of the original one. Okay, and let's just set its intensity to 0, so it's basically like a black disc, and we turn on cast shadows. And you can see that this light is now casting a shadow from the other one. We see, as it gets in front, it masks out the other light, blocking its light like that. Obviously that's quite soft because we've of course got a large-ish spotlight. We jump back to the original and let's just bring the cone angle down, shall we? And we'll just bring its size down a bit as well, and now we can see much more plainly how that light that is set to cast a shadow is able to basically cast a shadow as if it were a polygon object like that. Of course, I'm sure you'll remember back in Foundations when we looked at, the ways that PBR stuff could be done in earlier versions of Lightwave, how we could have the light, but we could also get a luminous polygon and put that at the same location, the same size as the light, and that allowed us to have a light be visible to camera and to cast shadows and be seen directly in reflections and so on and so forth. This is one of the things of lights that we no longer need to do that. It is built into lights and it is there in every respect. So let's take a little look at something else. We've got a point light here, and a point light is pretty simple and straightforward. It's just a point and the light is emitted from that singular point in space. You'll notice it doesn't have any of the size options, and even though it's got the visible to camera option, you don't actually get to see it because of course it is just an infinitely small point. It also of course casts harsh shadows, so you can think of this a bit like a directional light, except it's casting light in all directions rather than in a single direction, and also that light is centered on a specific point of emission. We can take a spherical light. Spherical light is sort of the same idea as a point light, except rather than being an infinitely small speck, it is of course a sphere and it has actual size. We can set it to 0, in which case we get basically the same effect as we would get from a point light, but normally you would make it, some size or other, and you get this little sphere, which is of course a nice light. And again, you can notice that as it gets bigger, as the size is increased, it has ever softer shadows. Notice of course also that the size parameter here is what drives the size of it. You'll notice that if we try and use the size tool, that doesn't apply to this light. Sizing is done directly from this parameter. It also has the option to use an image, and the image will automatically be mapped as a spherical map. You don't have any alternative options for how you map an image around a spherical light. It will always be mapped in spherical mode or spherical coordinates. But of course it will use that image to cast its light, though of course, because it's very soft, that image becomes very diffuse, so you don't see a great projection of it onto other things in the lighting. We then have linear lights. These are basically just, as the name suggests, a line of light. We have a size here, which is the diameter of the thing, so as that gets bigger, then it gets, thicker in that regard, and then you have a length setting for how long the linear light is. And basically, this is like a fluorescent tube light or something. That's all there is to it. We can notice it also has this checkbox here for ends, which will cause light to be emitted from the end caps of the cylinder as well. With ends turned off, then it's emitted only from the main surface between the two ends like this. Most commonly, of course, you would have ends off if you are doing something like a neon strip light or a tube light for a kitchen or what have you, and you'd probably have something like ends on if you were going to use it to be, say, a lightsaber. Next we have photometric lights or IES lights. By default, switching to it, you'll notice that I get nothing here. What a photometric light requires is it requires a data file, commonly known as an IES file, and these are data metrics taken from real-life light bulbs, most commonly by the light bulb manufacturers. So, for instance, you can go and have a look at somebody's website, like for instance Philips here, and it shows you the different models of light bulb that they produce, and of course you've got the IES files there that can be downloaded. Once you have that loaded up, then your light behaves in the same way that the real-world light bulb would do. And you can see down here you have a little thumbnail preview of what the cast from the light is like, what its pool is like. You see various information on the metrics from the IES file, and of course you can look at the photometric info directly here. Most commonly, of course, this would be used in architectural visualization or similar, where the plan is to use a specific type of light bulb in a given area, or you want to play around with different ones and you can get a look of how it will appear with the actual lighting in place. Next we have the environment light, and again you get this little sort of spherical icon for it. Notice that the little lines are pointing inwards on this sphere, unlike the spherical light where they point outwards. Again, this is sort of similar to the distant light, as in the fact that the light is not emanated from the point of this icon. Rather, the light is coming from all around. It is coming from the full environment. It is taken as if being an infinite distance away, but rather than an infinite distance away from a given direction, like the directional light, it is in all directions. Now, the important thing to notice with this fella is the sample backdrop option. With that turned off, then it's just, whatever colour that you care to set the lighting to here. However, the most common way of using this is in conjunction with a backdrop. So for instance, if you've got an HDR or you're using a gradient or whatever, then you turn sample backdrop on and the environment light will project that backdrop as real light. So there's our HDR environment here. You can see off in the distance there's some lights or other in this backdrop, and of course you can see that those lights are being reflected here in the specular. They're coming from the environment light. Of course, this is very similar to having a backdrop and using global illumination to light up your scene, taking the illumination from the backdrop image or gradient or whatever else. What the environment light really gives us is something that is quicker to render than global illumination. It also gives us this effect where we tend to get better shadows than we would get off direct GI. So of course you can see the very bright lights that are off to screen right over there are projecting a very nice clear shadow over here. Additionally, there's some other lighting, further off to the front of this object, and you can see we're getting a bit of shadow on the back side of him there. And also there's another very faint shadow just here, which is from some lights off to sort of screen left there. There are very specific ways of working with the environment light in combination with the glossy reflection options and also with global illumination itself, and we'll see that in detail in another video. The next one that we'll look at is this guy, the area light, quite large there, and this can be sized directly. You'll notice there's no size parameter for it in the interface. You just size it with the sizing tool, and this basically just gives you a light panel like a softbox. Like other lights that we've seen, when it's got a smaller size you get sharper shadows, and when it's got a bigger size you get softer ones. And it's a very common light to use to get sort of studio lighting type looks, because of course it does have this softbox effect. It can also of course take an image and project an image that way, and when it is visible to camera, of course, you see that image on the light itself. This makes it useful if you're wanting to do things like, neon street signs, like imagine a Times Square, right, where you've got all of these big lit up sort of signs and advertising. So rather than trying to model those or do something with luminous geometry and GI, you can instead just take image maps, put them on area lights, position them around, make them visible, and you'll get the proper lighting and the proper appearance of the brightness and everything else. The other thing that area lights do, similar to environment lights, is to have this option of portal. What a portal light does, if you just let me toggle it off there for a moment, okay, we can see that we've got white light in accordance with our light color, but when I turn on portal, then we get something different. What this is doing is effectively, it is giving us a cookie cutout of the backdrop. Now, even though I've got visible to camera on, I'm not seeing much, right? It doesn't appear to be making much difference, but actually the background image is seen here on the light. This will be more obvious if I just turn the light intensity up there. So I'll just turn the intensity up to 2, and you can see that in the place where the area light is, then the background image is appearing brighter. So whereas the environment light gives us, the background from all directions, the area light, when used in portal mode, becomes something of a window to the backdrop. So now it's not the whole backdrop that is lighting up our guy here. It's as if, we were in an enclosed room and this was a window and the backdrop light were coming through that window. That is effectively the effect that we're getting from this portal light. And again, because of course, we've got these multiple light sources in our backdrop image here, you can see how that's playing out and giving these multiple casts from the window. Generally what we tend to do is when we're doing outdoor lighting, we tend to use the environment light, and when we're doing interiors, we tend to use portal lights. And again, we'll look at using portal lights in that way in more detail in another video. Lastly then, we have this fellow, the ngon light, and the ngon light is basically exactly the same thing as an area light. The only difference is, whereas an area light is always this rectangular shape, this four-sided shape, with an ngon light we can have any number of sides we desire. So we can go anywhere from a triangle to, let's just say we go up to 50 sides, at which point we're basically approximating a circle. Otherwise it has the same options, so of course it can also be a portal. It can also use a projection image like this. Notice, of course, the projection image on the ngon and area light is just a straight planar projection. And this simply just then gives us the option to have area lighting of any shape that we desire. So, of course, if rather than wanting to do windows, we were wanting to do an interior with, let's say, portholes, then we could set up circular area lights, use a portal option, and there we have it. The last light then to mention is this guy, the primitive light, which is a kind of mesh light. It allows you to take a mesh in your scene and essentially turn it into a light, or create a light that matches the mesh. You can see here that its icon is a bounding box that fits around whatever mesh it's referencing, and you can see it's got a setting down here for primitive, which is where you select one of the meshes in your scene to be the actual reference mesh. Do note that it is based on its own position, not the position of the mesh. So if the light is moved, and you can see that that's there, but if I bring up the mesh, well, the actual mesh itself is still over here. So the light can be detached from the mesh. It doesn't automatically, when you create a primitive light, a mesh light, it doesn't automatically jump to the mesh. What I usually do is take the light and parent it, make it the actual child of the mesh that it's responding to, and just set it to 0, 0, 0 in both position and rotation, of course, and make sure that its scale is set to 1. Then, of course, it'll be properly placed on the mesh that it's referencing, and also you can position it just by positioning the mesh itself, so it'll go wherever the mesh goes and size wherever the mesh sizes. It is also responsive to deformation, so if you've got, displacement or bones or anything else that are actually displacing the mesh, then using that will indeed take the mesh light along with it. So the mesh light can be, or the primitive light I should call it, will be deformed along with your actual mesh. Notice, of course, that this doesn't reference a part of a mesh, it references a whole mesh. So, of course, if you're using this for, a light bulb or a light up object, whatever it happens to be in your scene, then that can't be part of another model. You need to have it as its own independent mesh or its own independent layer in an object file. One thing that you'll notice is this sample surface button here. With that turned off, then the light is, of course, again, it's just whatever color that you happen to have set for the light, and that's that. But with sample surface on, then it takes its surface properties from the actual surface, and in this case the Buddha mesh. If I turn it back on here, and I'll just hide the mesh light, you can see that the Buddha mesh has indeed got a texture on its color channel here which is just this red and white flowery pattern like that. What you also notice is that the luminosity, when you've got sample surface turned on, the actual luminosity of the light comes from the luminosity setting of the surface. So rather than controlling it from here, you would normally just set the light intensity to 1, and you would actually use the luminosity on the surface to determine how bright the light is supposed to be. One of the things with this light, of course, is the fact that you've also got the mesh in the scene. And the reason that I'm turning the mesh on and off here is because you'll notice that what happens if I turn the mesh on for rendering is we see this effect where the reflection in the tabletop here has become doubly bright. That's because what it is reflecting is both the light and the actual surface geometry. So they're both being reflected. Of course, if I were using radiosity, then I'd be getting illumination coming not just from the light, but also from the mesh. Now, you can, of course, fiddle around with this in object properties. You can do things like unseen by rays, so that turns off the reflection thing, and maybe unseen by radiosity, and change its shadowing, because, of course, you don't want it casting a shadow from the light, because, of course, their geometries are intersecting. Or you could use the exclude options here to exclude it from that primitive light, from the radiosity caustics and so on. Or maybe you have it seen by rays, so the mesh is appearing in reflection, but you turn off the effect specular on the light itself. You can balance it out in any number of ways with these different include and exclude checkboxes. Frankly, the easiest way to use it is just have diffuse, specular, all of that stuff on for the actual light itself, and for the mesh, just uncheck it in the scene editor so it doesn't render at all, which is the same as having it as unseen by rays, unseen by camera, no shadowing, all of these things excluded, and so on and so forth. But you can ignore all of that just by simply turning off the mesh item itself so it's never rendered. And when set like that, then everything is just coming from the light and you treat it as you would any other light source, with the exception, of course, with the luminosity which you would take from the surface, unless, of course, you are just wanting a fixed color light up object. If it were a light bulb or a neon sign or something, you might want to do that. Otherwise, this light type is very useful, especially in certain interior scenes where you've got lit up objects like, light bulbs or whatnot, that you want to cast light into a scene from an actual mesh, where you would normally use global illumination to cast those rays. That will be much slower. Using the primitive light will be much quicker in those situations. Of course, in many you might be able to use something like a sphere light or a linear light or a textured area light if you're wanting to do the light coming from a TV screen or something. But for those objects that are irregular shapes and where you can't really fake it with one of those light types, and especially where you've got some sort of texture that needs to be shown off, then the primitive light is an ideal choice and very useful. So there we have it. That is the overview of the light types that we have available to us in Lightwave, their different functions, their different effects, and all of the settings and options that are common and spread across them. In upcoming videos we'll look in more detail at certain aspects of the lighting, and also, of course, we'll look in detail at the workflows of using some of the specific light types in specific situations, so that when you are setting up your scenes you can pick the appropriate lights, use them in the proper ways, and get lovely looking and correct results from them in your renders.